Alright, we look at example 2. So here, the bearing of B from A is 62 degrees. So the first thing I'll do is to draw a north line. The bearing of B from A. So we start at the point A and we're going to B at 62 degrees. Alright, let me just make a sketch quickly of the diagram that we'll use. Good, so I know here is north, south, east, west. This will be 90 degrees. 135, 180, 225, 270, 315. Here it will be 0 or 360. And you can write 0 as 0, 0, 3 zeros. Here 0, 45 degrees. Good, so we'll use this diagram to help us. So since we're on 62 degrees, during this part will be 62 degrees. Good, so okay, let me just make a sketch. Again, you don't have to be accurate, right? Let's say if you use a protractor, measure this and you have 70 degrees, no problem. Good, so here we have 0, 62 degrees. Okay, this question have two parts. So the bearing of B from A is 62 degrees. What is the bearing of A from B? So this is a reverse to this question. Here it says the bearing of B from A is 62 degrees, and now it's saying what is the bearing of A from B. So from B means that we are starting at point B. So since we are starting at point B, we need a north line. So what I'll do, I'll draw a north line at point B, and this north line should always be perpendicular, meaning that it should go straight up, right? Should not be like slanted, should be perpendicular. Good. So what is the bearing of A from B? So we start at B from the north line. We go in a clockwise direction. So we need to find this bearing here, right? We need to calculate this bearing. So the way we can work this, what I can do, I can project this north line. Project it. Good. So since I project this north line, I know from here to here, since this is a straight line, from here to here will be 180 degrees. Good, so from here to here will be 180 degrees. And let's say we have two north line. There's something called an alternate angle or Z angle that is formed. What this means that this angle here will equals to this one at the bottom. So from here to here will be 62. So all we need to do, so we know from here to here is 180 degrees since it's a straight line. And this angle, whatever angle we have there, will be equals to this. If you look, you'll see something like a Z. We call this, a common name we use is Z angle. Good, so in here will be 62, so we'll add here. 8 and 6 will give us 14. 1 and 1, 2. So we get 242 degrees. So this will be our answer, 242 degrees. Okay, that's it. Number 1. Number 2. Draw my north line. Okay, S is on a bearing of 140 degrees from R. So therefore we start at point R and 140 degrees. So what we'll do, we look at our diagram. Here is 135, 140 should be around there. Good, so let me see. Alright, so here will be S. Start from the north line in a clockwise direction, 140 degrees. Okay, this question states now, determine the bearing of R from S. So we are starting at the point S. From S means that we are starting at S. So since we are starting at S, we need a north line at S. So here I'll draw a north line. The north line can be any height. Good, so we can stop there. If you want, you can draw a north line longer than that. It doesn't matter. Okay, so we need to know this bearing, the bearing of R from S. So we start from the north line, and this line here connect R and S. The same line connect, here is R, here is S. So that's why we need to get it like that. Okay, so actually we come over to this problem. Don't have enough space. So again, I'll project this line. Okay, so again, here's 140 degrees. This one on 140 degrees. At the bottom here will be 140 degrees, and from there straight to there is 180. So all we need to do is to add 180 plus 140. So 8 and 4, 12. Here we get 320 degrees. So here will be 320 degrees. Alright, next example. Alright, let me draw my north line force. The bearing of Q from P, so we're starting at point P, is 240 degrees. Okay, looking at this here, 225 is there, 240 should be within that zone. So let's see, my 240. Okay, a good way I should have erased P and put it there. Anyway, no problem. Good, so P, I put Q there. So here we have how much? 240 degrees. What is the bearing of P from Q? So since we are starting at the point Q, we need to have a north line. Good. Instead of us going like that, that will be anti-clockwise. So we need this bearing. So we start from the north line in a clockwise direction. Good. So we need to determine how much is this angle, right? We know that this entire angle is 240 degrees. So what I'll do now, this question is a little different from the first two. I'll project this line. Good, so since I project this line, okay, let us look back at the first example. Remember I told you that this angle and this one at the bottom is equal, right? Good, so let's say if I can figure out this angle here, this angle and this angle will be equal, and we know that this entire angle is 240 degrees, and from here to there is 180 degrees. So for us to get this part, all we need to subtract. So 240, we take 180 from 240. How much we'll have? 60. Alright, 0, 60. Okay, we have 60 degrees. So here will be 0, 60 degrees. Alright, final problem. Okay, first thing I'll do is to draw a north line. Let me draw it here. N is on a bearing of 340 degrees from M. So we start at the point M, and since it's 340 degrees, okay, let us look back at this diagram. 340, 315 is there, so 340 will be very close to the north line. Good, so what I'll do here, okay, I should cancel this and probably draw the diagram here, because see, like I run out of space. So here's M. It's very close to the north line.